So I have showed you how to integrate the surface integral of some function, and this function I have taken it as a scalar function. But of course you can also do integrals of a vector function, okay? And as you know, this will have applications, for example, in calculating the center of mass. For example, here you have a surface integral and the integrand is a vector, yeah, because you have the r position vector there. So you have to be able to do surface integrals of a vector. And the way to do it is very easy. As usual, when doing integrals of vectors, you just have to do the integral of each component. So this integral will be a vector itself, so the result is a vector, and this is the surface integral on the surface S of some vector function f times ds. So you can write your vector function f by expanding it in a basis. So you can, for example, use the x hat, y hat, z hat basis. Where now each of these components will be a function. And so now you can use the linearity of the integration to get the constant basis vectors outside and split the integral into 3 parts. So you get x hat times the integration of fx ds plus y hat times the integration of fy ds plus z hat times the integration of fz ds. Okay? In other words, another way of writing this is that your integral, which is the integral of this vector fx, fy, fz ds, this becomes equal to a vector whose components are the integral of each of the components. Okay, so I'm writing the same thing on the top row as in the bottom row. I'm just using the basis vector expansion or the column format for vectors. As an example, I can write here the center of mass for a surface. So you know that the position for the center of mass of a surface is given by the surface integral of r times the surface density times ds divided by the surface integral of the surface density times ds, and this here is the total mass of the surface. Okay, and as you know, this will be equal to 1 over the total mass. And now you have to do the different integrals for the different components. So this would be the surface integral of x times sigma ds plus y hat times the surface integral of y times sigma ds plus z hat times the surface integral of z times sigma ds. Okay, and this is indeed a vector which gives you the different components of the center of mass. If you wanted to calculate the geometric center without taking into account the mass, then you would just remove the density, and that will be a way to calculate the geometric center. So let me write it. This would be center of mass. But you could also calculate the geometric center. Geometric center means that if this is a certain shape, what's the center in terms of the geometry, regardless of how the mass is distributed, okay? And the geometric center is just similar to the center of mass, but without the mass density. So that the bottom now is the total surface. Okay, but the top can still be divided into x hat plus y hat plus z hat. Okay, I hope that's clear. See you in the next video.